very thankful for that, ma'am. So today my topic is Indian knowledge system perspective to mathematics. Generally, mathematics we can have vast knowledge. So previously, what are all the contributions of our famous Indian mathematicians? Just I have some review about all those things. I am trying to share that with my co-researchers. Thank you. Is my screen is visible?
Yes, ma'am. Can you just present it in slideshow mode, ma'am?
Yeah, that's right. Yeah, it's okay.
Yes, ma'am. Thank you.
Systematic transfer of knowledge from generation to generation, it's not simply a tradition, but well structured and process of knowledge transfer. It is the knowledge system. So mathematics in India has a very rich, long and hallowed history. Starting from the most elementary things in mathematics, namely the representation of numbers through the way of expressing recursive relations to arriving at the solution of indeterminate equations to the development of sophisticated techniques in handling the infinite and the infinitesimal Indian mathematics. So the Indian mathematicians have made remarkable contributions. So it is playing a significant role in the Indian development of culture and tradition. The ancient mathematics in India or the Vedic mathematics had begun in the early Aran age. The Shatpatha, Brahmana and Sulabha Sutra, including the things like irrational numbers, prime numbers, rule of three and square roots also solved many of the complex numbers. So what is this Shatpatha Brahmana in Brahmi script? This is the oldest extant text explicitly state and make use of the so-called Pythagorean theorem. Besides giving various interesting approximations to surds like Pingala Chandasastra, a text that deals with the Prisodi lays foundations for various combination techniques. Now, coming to another famous mathematician, Brahmagupta, he was an Indian mathematician and also an astronomer who wrote two important works on mathematics, the Brahma Stupa Siddhanta and the Khadakayaka. He was the first mathematician to use the concept of zero. But now people don't know who is Brahmagupta mathematics, what he's derived from. We have another famous mathematician, Aryabhatta. He is the presenter of the differential equations of sine function, its infinite difference from, and a method for solving the linear indeterminate equations. The mathematical contributions of Aryabhatta covers arithmetic, algebra, plane trigonometry, spherical trigonometry, and also he covers continued fractions, quadratic equations, sum of power series, and a table of signs. So he correctly insisted that the earth rotates about its axis. Suppose, and also he approximated the value of pi. Add 4 to 100, multiply by 8, and then add 62,000 by this rule. The circumference of a circle with a diameter of 20,000 can be approached. This implies that the ratio of the circumference to the diameter is almost 4 plus 100 into 8 plus 62,000 divided by 20,000, which is approximately equal to 3.1416, which is accurate to the 5 significant figures. And also Aryabhatta contributed elegant results for the summation of series of squares and cubes. He mentioned that algebraic formula. Every day, the students, if we are going to ask them what is a plus b whole square, they are having the recitation of the knowledge, something like a square plus b square plus 2ab. So at that ancient time only, these are the people invented the number system and the decimal system also. He put more approximate uses of decimal systems in 2D figure. He gives the formula for areas of 2D figures and volume of spheres and cone, volume of a pyramid, half the product of base and height, arithmetic series. He gave a rule for summing an arithmetic series after this. So he tried to solve the indeterminate linear equations like ax plus by is equal to c. His contribution in geometry are commendable. Trigonometry, he gave considerable attention to trigonometry. And also the first Indian satellite is also called as in that name Aryabhatta. Another famous mathematician, Bhaskara too, or he is also known as the Bhaskaracharya. He had the famous three mathematical granthas, which are Lilavati Ganitam or Lilavati Shankaracharya, Bija Ganita or the algebra of the Hinduism, Siddhanta Siromani. So this Bhaskaracharya was an Indian mathematician and also he is an astronomer of 12th century AD. He is referred as Bhaskara too to avoid the confusion. He represented the peaks of mathematical knowledge in 12th century and was the head of the astronomical observatory at Ujjain, the leading mathematical center of ancient India. One more grantha of his Siddhanta Siromani, Sanskrita means crown of treatise, is divided into four parts. They called the Leelavati, Bijaganita, Grahaganita, and Golodhyaya. Grahaganita, mathematics of planets. Golodhyaya, nothing but the study of spheres or earth. So these four sections deals with arithmetic, algebra, mathematics of the planets and spheres respectively, and also wrote another treatise named Karma Kuttahula. What are all his contributions to mathematics? A proof of the Pythagorean theorem by calculating the same area in two different ways and the cancel out times to get the value, suppose c square equal to a square plus b square, solved in quadratic equation with more than one unknown found, negative and irrational solutions. So there is a famous sloka to calculate the Pythagoras theorem. Easily they can calculate here. Nothing but Tiryagakansya Raju Tiryadamani Parsvamani Cha Yat Krudota Krutatana Karoti iti Karanam. Means a rope stretched along the length of the diagonal produces an area which is the vertical and horizontal make together. That is nothing but our Pythagoras theorem. He gave the preliminary concepts of mathematical analysis, infinitesimal calculus, along with notable contributions towards integral calculus, conceived differential calculus after discovering the derivative and differential quotients. He gave the statement the proof of important theorem, Rolle's theorem. A special case of one of the most important theorem is analysis, the mean value theorem. Traces of the general mean value theorem are also found his work. Calculated the derivatives of trigonometric functions. In Siddhanta Siromani, Bhaskara developed spherical trigonometry along with a number of other trigonometric results. So Bhaskara's contributions to arithmetic text Lilavati covers the topics of definitions, arithmetical terms, interest computations, geometrical progressions, plane geometry, solid geometry, the shadow of the Eunomian methods to solve the indeterminate equations and combinations. He have given some contributions to trigonometry also. The Siddhanta Shiromani, the demonstrates Bhaskara's knowledge of trigonometry, including the sine table, the relationship between the trigonometric functions. He also discovered the spherical trigonometry along with other interesting trigonometrical results. In particular, Bhaskara is more interested in trigonometry for its own sake than his predecessor, who saw it only as tool for calculations. What are his contributions to calculus? In Siddhanta Shiromani is an astronomical treatise and contains many theories not found in earlier works. Preliminary concepts of infinitesimal calculus and mathematical analysis, along with the number of results in trigonometry, differential calculus, integral calculus, these are all found in the work are of particular interest. So many evidences are saying that Bhaskara was acquainted with some ideas of differential calculus. He understands the utility of his research to historians of mathematics generally, goes deeper into differential calculus and suggests the differential quotients vanishes at an extreme values of the function, like we are calculating the maxima and minima, indicating the knowledge of the concept of infinitesimals. He uses the results to work out the position angle of the elliptic quantity required for accurately predicting the time of an eclipse. And his contributions to astronomy. So, using an astronomical model developed by Brahmagupta in 7th century, Bhaskara accurately defined many astronomical quantities, including the length of the sidereal year, the time that is required for the Earth to orbit the Sun, as 365 days 0.2588 days, which is same as in Surya Siddhanta. The modern aspect measured is 365.2563 days, a difference of just 3.5 minutes. Here we have 365.2588 and here it should be 365.2563. How accuracy they gave at that early ages of our ancient culture. His mathematical astronomy text Siddhanta Shiromani is written in two parts, mathematical astronomy and the second part on the sphere. The 12 chapters of the first part are covers mean longitude of the planets, true longitude of the planets, the three problems of diurnal rotation, lunar eclipse, solar eclipse, latitudes of the planets, sunrise equations, moon's crescent, conjunctions of the planets with each other. These conjunctions of the planets with the fixed stars, the path of the sun and the moon. The second part is containing the sphere. It covers the topics such as price of study of the sphere, nature of the sphere, cosmography and geography, planetary mean motion, eccentric eclipse model of the planets, the armillary sphere, spherical trigonometry, eclipse calculations. These are all the contributions of great mathematician Bhaskar. Haribhat. Brahmagupta, he was born in 598 AD in Binmal city, state of Rajasthan. He is renowned for introduction of negative numbers and operations on zero into arithmetic. He was an Indian mathematician and an astronomer who wrote many important works on mathematics and astronomy. The main work of Brahmagupta, which was of astronomy theory, this work was given by a social Hindi formulated the rule of this, and he goes to the famous of areas of cyclic quadrilateral as where is the semi-perimeter. Brahmagupta's theorem states that if a cyclic quadrilateral is orthodiagonal, then the perpendicular to a side from the point of intersection of the diagonal always bisects the opposite side. More specifically, suppose we have these are the 4 points on a circle such that the lines AC and BD are perpendicular, denote that these are intersecting at a point, say M. Drop the perpendicular from M to BC, calling the intersection of E, F be the intersection of the line EM and the edge AD. Then this theorem states that F is the midpoint of AD. And we have one more mathematician, Mahavira. He is an Indian mathematician from Gulbarga who asserted that square root of a negative number did not exist, that we all know. He gave the sum of a series whose terms are squares of an arithmetic progression and empirical rules for area and perimeter of an ellipse. He was the patronized by the great Rashtrakuta king. Amongst Mahavira was the author of Ganit Sara Sangraha. Next, we have the famous mathematician Srinivasa Ramanujan, one of the greatest mathematical genius. He made substantial contributions to the analytical theory of numbers and worked on elliptic functions, continued functions, and infinite series. Here we can go with the culture also produced artistic design of mathematical nature, and there is evidence in carving that these people could draw concentric and intersecting circles and triangles. The civilization and culture of the inhabitants of the Indus Valley were a very advanced nature. There are many unique features in the construction patterns which suggest independent origin of ideas in ancient Indian civilization. If you want to see the uses of circles in decorative design, there is indication of use of bullock carts, the wheels of which may have had a metallic band wrapped with the corresponding points to the position of knowledge. The rate of this length of the circumference of the circle and the diameter and thus values of pi. Here we can see the patterns suggest that independent origin of ideas in ancient civilization. So we have a great interest is a remarkable accurate decimal ruler known as the Mohenjo-daro ruler. Subdivisions on the ruler have a maximum error of just 0.005 inches and at a length of 1.32 inches have been named the Indus inch. Furthermore, a correspondence has been noted between the Indus scale and the brick size. This brick size is found to have dimensions that were integral multiple of the graduation of their respective scales, which suggests the advanced mathematical thinking. This culture has provides the system of uniform and decimal weights over a vast area are of considerable interest. Also, many of the weights uncovered have been produced in definite geometrical shapes like cuboid, barrel, cone, cylinder, which presents the knowledge of basic geometry, including the circles. The civilization here attracts how the famous mathematicians are contributing to our culture. Not only here, so every Indian is having the responsibility of to preserve the such type of knowledge and culture. Not only that Indian, this is the responsibility of the person in the entire world. Even we are studying the different subjects like aeronautical engineering, medical, computer science, electronics engineering. These are all the sastras already existed in our famous Indian culture like Vaimanika Sastra, aeronautical engineering, Vedic mathematics, Ardha Sastra, economics, Charaka Samhita. So, what not in everywhere our corresponding contributions are there. Now, coming to Leelavati Sakuntala Devi, she was born in 1939, an Indian calculating prodigy. By the age of 6, she demonstrated her calculations and memorization abilities at University of Mysore. At the age of 8, she had success at Annamale University by doing the same. She demonstrated the multiplication of 13-digit number picked it randomly by the computer department, Imperial College London. She answered the question in 28 seconds. However, the time is more likely the time for dictating the answer. So in Dallas also, she had a contribution with the computer to see who give the cube of this faster. She is the only person won that. Now she is known to be the human computer. And we have one more famous mathematician, statistician, Mahalanobis Distance. He contributed here to find out the descriptive statistics provides a relative measure of data points distance from a common point. It is a needless measure inducted by Mahalanobis in 1936. The distance used to identify gosmilarity of an unknown sample set to a known one, it differs from Euclidean distance in that it takes into account the correlation of the data set and is scale invariant. In other words, it has a multivariate effective size. Here we have Kalampudi Radhakrishna Rao, namely known as that C.R. Rao, in our Hyderabad, Gachibowli near Central University, we have C.R. Rao AIMSCS, Institute of Mathematics, Statistics and Computers. The road is also given his name only, C.R. Rao Road. So his contributions to statistics and mathematics is commendable. I had an opportunity to meet him in for 10 years back only because we are there to have that statue of Ramanujan at their institute. They invited us from our college students. We had an opportunity to meet him. I think recently sir was passes away. He was not there physically. So his contributions to statistics, his honorably numerous degrees, and he had the best known discoveries of all the crane bound and the Rao Blackwell theory related to the quality of estimator. Other areas he worked in include the multivariate analysis, estimation theory, differential geometry. His contributions are including Fisher-Rao theorem, Rao distance, and orthogonal arrays. He is the author of 14 books, has published over 400 journals. He is the living legend of mathematics and statistics. What not? He had many contributions to mathematics. So the Kerala School of Astronomy and Mathematics, founded by Madhava of Sangama Graham in 1300, was responsible for many first in mathematics, including the use of mathematical induction and some early calculus related results. Also, systematic rules for calculus were developed by the Kerala school. Its proponents first conceived of many of the results that would be later repeated in Europe, including Taylor series expansion, infinitesimal, and differentiation. The Lee made in India, the transform zero from a simple placeholder to a number is known as the right indicates the mathematical enlightened culture that was flourishing on the subcontinent at the time when Europe was stuck in the dark ages, although reputation suffers from the Eurocentric bias. The subcontinent has a strong mathematical heritage which continues into the 21st century by providing key players at the forefront of every branch of mathematics. The appearance of evidence of the use of mathematics in the Indian subcontinent was given by systematic uniform number systems and also the corresponding contributions to the famous mathematicians. If you want to take a primitive forming context, a farmer owes another farmer 7 cows, for example, then effectively the first farmer has minus 7 cows. If the first farmer goes out to buy some animals to repay his debt, he has to buy 7 cows and give them to the second farmer in order to bring his cow totally back to zero. That means what? European mathematics were reluctant to accept negative numbers as meaningful. So many look at the value that negative numbers were absurd. The reason that numbers were developed for counting and questioned what could be the negative numbers. So Indian and Chinese mathematician recognized early and that one answer is nothing but this cow problem. So basis for calculus is we can have zero held European mathematics. Gottfried Wilm was one of the first European to use the zero and the negatives in a systematic way to development of the calculus in 17th century. This calculus is used to measure the rates of changes and it's important in almost every branch of science, notably underpinning many key discoveries in modern physics. Am I audible? Yes?
Yes, ma'am.
Yeah, yeah, 1 second, ma'am. See, despite of the development quite independently, one of the basic history and archaeological conclusions, the history of Indian subcontinent may be divided into different types of aspects. For example, if you want to take that aspect of mantras from the early Vedic period, invoke the powers of 10 from 100 all the way up to trillion and provides evidence of the use of arithmetic operations such as addition, subtraction, multiplication, fraction, squares, cubes, and finding the roots also. In 4th century AD, Sanskrit textbooks reports Buddha enumerating numbers up to 10 power 53 as well as describing 6 more numbering system over and above this, leading to a number which is equivalent to 10 power 421. Given that there are estimation of 10 power 80 atoms in the whole universe, this is close to infinite as any in the ancient world. It also describes the series of iteration in decreasing size in order to demonstrate the size of an atom, which comes remarkably close to the actual size of a carbon atom, trillions of a meter. As early as 8th century BC, a text known as here triples as the statement of the simplified theorem that gives the triples as well as the statement to the square root and the rectangle. The basic geometry here, including geometric solutions of linear and quadratic equations, which are remarkable accurate figure for the square root of 2. Similarly, at the early of 3rd and 2nd century BC, the Jain mathematicians recognized 5 different types of infinities. Infinity in one direction, two direction, in area, infinity everywhere, and perpetually infinite. So ancient Buddhist literature also demonstrates a persistent awareness of indeterminate and infinite numbers, with numbers deemed to be 3 types: countable, uncountable, infinite. Suppose if you want to check about the Indians who are responsible for another hugely important development of mathematics, the earliest records usage of a circle character for the number 0 is usually arbitrated in 9th century engraving in a temple in Gwalior in central India. But the brilliant conceptual leap to include 0 as a number in its own right is usually credited to the 7th century Indian mathematicians, or possibly another Indian, though have been practical use for centuries before that. The use of 0 as a number, which could be used in calculations and mathematical investigations, would revolutionize the mathematics. What not? In every contribution, the famous Indian mathematician's role is very much significant. Now, so-called, we are in the uh, scenario of artificial intelligence and machine learning. There also the sutras, what is there, the calculations, binary system, number system, decimal system, these are already inculcated with the thousands of years ago only. Suppose you want to take the concept of the data analytics. We are deriving this data from many aspects, whether the data is taken from the primary data or the secondary data. Primary data in the sense it can be taken from directly from the government institutions or DRDO, where the research purpose are taking the data from the internet sources, and or this is the secondary data. Whether the data is collected primarily or secondarily, we need to analyze the data, because in every minute, almost huge number of data is producing. Huge number of data is producing. As of now, today, 99% of the data is simply wasted, because using the data, if you are not doing a proper insight with the data, there is no use of analyzing the data. That is the reason we have the concept of data analytics. While getting the data, we will go with the data can be collected from any of the source, and we need to pre-process the data, cleanse the data, and then apply different types of algorithms to get the better predictive model. While getting this better predictive model, in the sense, we need to check this is the data can be applicable for the real-time applications or not. In that scenario, the data is collected from any source. While applying the different types of algorithms, the feature extraction is very, very important. To take this feature extraction, the algorithms what we are using, these are all the basis with the famous Indian mathematical system only. To take any of that algorithm, we can do with the binary search algorithm. This is all taken from the binary system only. So we can give minimum responsible. As an Indian, we have to take the minimum responsibility of to preserve our ancient Indian culture, have the good knowledge about this mathematics, instead of going to somewhere and inculcating different types of habits. We have to inculcate such a type of habits to preserve our knowledge. Now, coming to here, I'll tell you one thing. The contributions of Bhaskaracharya, he gave here the term cancelling the area in two different ways. The cancelling the term solving the quadratic equations with more than one known and found negative and irrational solutions. So, to simplify such type of situations, we can have the multiplication and squaring inverse rules are also can be taken. Another grantha of another grantha of Bhaskaracharya in Bija Ganita, he explained about effectively algebra and contains the topics related to zero as well as the negative numbers. Just now we discussed about that cow problem. No? So the existence of negative number is also with his contributions only. What not in every aspect, if you want to go to the corresponding literature, we can have n number of ways to simplify such type of famous Indian mathematical system, which is having a practical role. The number system, the concept of zero, then the solutions of the quadratic equations, rules of negative numbers, basis for calculus. These are all the things given by our famous mathematicians only. So our what is our role if we are taking here and there to contributing something or researching something? As a researcher or as a student or a scholar, we have to inculcate the habit of to preserve such type of granthas and whatever the knowledge we are acquiring to share to our coming generation also. Madam,
Yes, ma'am.
so with this, I am ending here because these are all the things I took it from that internet only. My contribution is, I don't have any contribution here. I'm not doing any hands-on session. Just whatever the knowledge I am taking from that internet, just I am sharing to the co-scholars or my uh, suggestions. Any suggestions or anything, ma'am?